Use of composite functions, part 2. Let us recapitulate the theorem. If y equal to f of u is a differentiable function of u and u equal to g of x is a differentiable function of x, such that the composite function y equal to f of g of x is a differentiable function of x, then dy by dx equal to dy by du into du by dx. Here y is expressed in terms of u, and in turn u is expressed in terms of x. Therefore y is indirectly a function of x. Hence this is a composite function. So this is the formula for composite function. Let us directly get into the examples. If f of x equal to square root of 7 times g of x minus 3, g of x equal to g of 3 equal to 4, and g dash of 3 equal to 5, then find f dash of 3. So we write down the given function as it is first, then differentiate with respect to x. So dy by dx equal to d by dx of square root of 7 times g of x minus 3. Here this is a composite function because the outermost function is root and inner function is 7 times g of x minus 3. Here it is something like square root of u, and the derivative of u is 1 upon 2 root u into d by dx of what you thought as u, that is 7 times g of x minus 3. Its derivative is here. So we get f dash of x equal to 7 times g dash of x upon 2 into root of 7 times g of x minus 3. Now for x equal to 3, we get f dash of 3 equal to 7 into g dash of 3 upon 2 into root of 7 times g of 3 minus 3. And here g of 3 is 4 and g dash of 3 is 5. On substituting, we get f dash of 3 equal to 7 by 2. Next is f of x, capital F of x rather, equal to g of 3 times g of 5 times g of x. And you are given g of 0 is 0 and g dash of 0 equal to 3, and then find f dash of 0. Given that the given function f of x as written as it is, differentiate with respect to x, f dash of x equal to d by dx of right hand side of f of x, and here this 3 times g of 5 times g of x, this is treated as u. Therefore the function becomes g of u, whose derivative will be g dash of u into derivative of what you thought as u. There this 3 is a constant, it comes out, and hence we find the derivative of g of 5 times g of x, and therefore it becomes g dash of 3 times g of x, g of 5 times g of x, 3 into g dash of 5 g of x into 5 times d by dx of g of x. So finally f dash of x is 15 times g dash of 3 times g of 5 times g of x into g dash of 5 times g of x into g dash of x. So here we are going to substitute x equal to 0. On putting x equal to 0, we get this expression, that is wherever the x was, and there we have substituted as 0, the value of x as 0, and therefore it becomes 15 times g dash of 3 times g of 0, g dash of 0 into 3. So this is the value of g dash of 0 from the table, from the given data, and g of 0 is 0, so 5 into 0 will be again 0 here, and here also 5 into 0 is 0. Therefore it becomes 3 times g of 0 and g dash of 0. Again here this becomes 0, and therefore what we get is 15 times g dash of 0 into 3, because g dash of 0 is 3, and therefore finally the result is f dash of 0 equals to 15 into 3 into 3 into 3 equal to 405. And we have got some set of values of f, g, f dash and g dash for a given value of values of x. So the values are like this. Using these values, you are asked to find r dash of 2 if r of x is f of g of x. Similarly, r dash of 4, s dash of 4, and s dash of 6 with the corresponding functions. So what you are given is rx is f of g of x, differentiate with respect to x. R dash of x is derivative of f of g of x. Here g of x is treated as u, so f of u, derivative of f of u is f dash of u into derivative of what you thought as u. Therefore, r dash of x equal to f dash of g of x into g dash of x. Now for x equal to 2, that means we are going to substitute x equal to 2 in the differentiated function. So we get r dash of 2 equals to f dash of g of 2 into g dash of 2. G of 2 is 6 and g dash of 2 is 4, and therefore it becomes f dash of 6 into 4. F dash of 6 is minus 4, and into 4, that gives you minus 16. Now r of x, g of 3 plus fx, differentiate with respect to x. R dash of x, derivative of g of 3 plus fx, that becomes g dash of 3 plus fx into derivative of 3 plus fx, and therefore r dash of x equal to g dash of 3 plus fx into f dash of x. Now for x equal to 4, so we get r dash of 4 equal to g dash of 3 plus f of 4 into f dash of 4. F of 4 is 3, so it becomes g dash of 3 plus 3, that is g dash of 6 into f dash of 4, and therefore r dash of 4 is 7 into 5 equal to 35. S of x equal to 9 minus fx, differentiate with respect to x, and this is the derivative part. So f dash of 9 minus fx into d by dx of 9 minus fx, and here 9 is a constant, therefore its derivative becomes 0, and this is minus fx, so its derivative becomes minus f dash of x, and that minus sign comes out and it becomes f dash of 9 minus fx into f dash of x. And here we are asked to find s dash of 4. So replace x by 4 in s dash of x. It becomes minus f dash of 9 minus f of 4 into f dash of 4, that is minus f dash of 9 minus 3, because f of 4 is 3, into f dash of 4. So it becomes minus 9 minus f dash of 6 into f dash of 4. So s dash of 4 is minus of minus 4 into 5, and that's equal to 20. S of x is g of x, differentiate with respect to x. S dash of x, that is d by dx of g of x, and it is the derivative part, g dash of g of x into derivative of g of x, and therefore s dash of x equal to g dash of g of x into g dash of x. Here we are going to put x equal to 6. So s dash of 6 equal to g dash of g of 6 into g dash of 6. G of 6 is 2, therefore it becomes g dash of 2 into g dash of 6, and g dash of 2 is 4, g dash of 6 is 7, and hence the final result is s dash of 6 equal to 28. And next is a paragraph problem, where this paragraph has some blank spaces in between. We have to fill in those blank spaces by using the hint basket given at the end of the problem. So what you are given is f of x equal to sin x, g of x equal to log x, and you are asked to express f of g of x and g of f of x, and you are asked to find f dash of x and g dash of x, the derivative of f of g of x with respect to x in terms of f and g. This blank is to be filled out. Therefore, derivative of f of g of x, we have to fill in this blank, and in this derivative we have to put x equal to 1. That means you are asked to find the derivative value of d by dx of f of g of x. And next you are asked to find the derivative of g of f of x with respect to x in terms of f and g. This blank is to be filled. Therefore, the derivative of g of f of x equal to, this is again to be filled, and when x equal to pi by 3, that is this part, you have to find d by dx of g of f of x. That means in the differentiated function you have to put x equal to pi by 3, and that is to be filled out here. So hint basket, what this hint basket is all about? It contains these values, and you are going to substitute. They are not in order, and we have to choose the proper value in the corresponding place in the blank spaces. So what the solution says is, you are given f of x equal to sin x, g of x equal to log x, and you are asked to find, or rather express, f of g of x and g of f of x, which is nothing but sin of log x, and here it is log of sin x, and the derivative of f of x is f dash of x replaced by cos x, and g dash of x, that is the derivative of log x, is 1 by x. The derivative of f of g of x with respect to x in terms of f and g is f dash of g of x into g dash of x. Therefore, d by dx of f of g of x equal to cos of log x upon x, and derivative of f of g of x when x equal to 1. That means you are asked to replace x by 1 in the differentiated function, and that gives cos of log 1 upon 1. Log 1 is 0, cos 0 is 1. And the other next part is the derivative of g of f of x with respect to x in terms of f and g, and this is given to be g dash of f of x into f dash of x. Therefore, d by dx of g of f of x is cot x, and therefore d by dx of g of f of x when x equal to pi by 3 is cot pi by 3, and that's equal to root 2, and that's done.